Hello students, in the last three classes we discussed about buoyancy, center of buoyancy and problems on center of buoyancy and metacentric height and problems on those we discussed in 3-4 classes. Today let us discuss the last bit of the first part of the second model, that is stability of floating body. Stability, it is determined from position of metacenter. In case of floating body, weight of body equals to weight of liquid displaced, we know it. Now let us know about stable equilibrium. You see in the figure, this is the normal position of the rectangular body. G is the center of gravity, exactly at the center and denoted by G, and B is the center of buoyancy. The forces center of weight through G and center of buoyancy through B in the upward direction means are in the same line of action, so there is no couple. But come to the second figure. Here when we give a small angular displacement to this body in clockwise direction, then the line of action of this normal body shifts to the new position. You see here, this is the line of action, and also the center of buoyancy is also shifted to the new position B1. So now the weight through center of buoyancy, the weight through center of gravity and force through center of buoyancy constitute together a couple which causes the body to rotate in the anti-clockwise direction. So it brings the body to the original position. So now we can say that it is in the stable condition. So for stable condition, the metacenter should always above the center of gravity. Now let us come to the second figure. Here unstable equilibrium. The body is unstable when metacenter lies below the center of gravity. You see here, when we give a small angular displacement to a rectangular body which is having some heavier weight at its top side. So because of this heavier weight, what happens here, when you give the angular position, the metacenter definitely comes below the center of gravity. Then what happens in the new position, the line of action of force F, means the buoyant force F through new line of action and the weight through center of gravity constitute together a disturbing couple which also rotate to cause the body to rotate in the same clockwise direction. That is why overturning of the body will not comes to the original position. This is called unstable equilibrium. So when the center of metacenter lies below the center of gravity, the body will be in unstable equilibrium. Let us go for one problem on this stable and unstable equilibrium of a body. Let us consider a solid cylinder of diameter 4 meter as a height of 4 meter. Find the metacentric height of the cylinder if the specific gravity of cylinder is 0.6 and it is floating in water with its axis vertical. State whether the equilibrium is stable or unstable. So according to the condition given in the problem, you have to sketch the figure. Draw a circle in the plan with its diameter 4 meter and its depth we can see in the immersion position, we can see in the front view or elevation. Here it means it is having a specific gravity 0.6. So this is the below the water. Above the water it floats certain portion and remaining portion immersed in the water and its length is 4 meter. Now let us come to the given data. Diameter is 4 meter, height is 4 meter, specific gravity 0.6. So in order to find the depth of immersion in the body, this is total is 4 meter. Total height of the cylinder is 4 meter, but depth of immersion we have to find out, that is h equals to 2.4 meter. So in order to find depth of immersion, we have to multiply specific gravity to the given height of the cylinder. According to that, 0.6 into 4 will give the 2.4 meter. So from figure, now we see from the base we have to consider the position, means the distance between center of gravity and center of buoyancy. So from base we have to mention it as A. So now from figure BG equals to, you see here BG equals to AG minus AB. So BG equals to AG minus AB, because BG is required to find out the metacentric height. So AG is 2 meter and half of AB, and half of AB. So 2 into half of 2 into half into 2.4 will get 0.8 meter. Now metacentric height is given by, metacentric height is given by means I is the moment of inertia of the plane of the body about y, that is pi d square by 64, and volume is area into length. Area is pi d square by 4 into 2.4 meter cube. So metacentric height Gm equals to I by V minus Bg. You know the equation. So according to that, whatever the given values by putting in this equation, we will get the final minus 0.38 meter. So since metacentric height here is negative, that is why metacenter lies below the center of specific gravity and the cylinder is in unstable equilibrium. You see here, because metacenter, here you see the metacenter lies below the center of gravity, though so the body is unstable, what I explained previously, the condition for unstable equilibrium. Thank you.